think that is all our business. So I want to introduce our speaker, and I have your bio in front of me, but I might just turn it over to you to introduce yourself to talk about Python tricks and features.
All right, cool. Well, first of all, the title's a little bit of like talk bait because I'm not going to talk about anything that's actually hidden. Everything is documented in Python, but I'm going to talk about type collections, metaclasses, and how we can use them. So my name is Dustin. That's my face. And I work at PromptWorks, which is a software consultancy in the city. And it kind of seems like PromptWorks is mostly well known in the city for doing Ruby development, but we actually work with a lot of different languages. And these days, it includes a lot of Python. I primarily only write Python, but we still have some Ruby devs hanging around our shop. So this means that every now and then, we get questions posted in our Slack that look something like this. So Jeff is originally a Ruby developer writing Python lately, and he asked this question, and he's irked. He's really upset he can't do this in Python. And if you know Jeff, you know he's usually irked, but here he's particularly irked. So I saw this, and I said, all right, I know all about Python. Why can't you do that? It's actually kind of weird. Object is a reserved word. We can instantiate it like that, but when you try to set an attribute on it, such as there, what happens when you try to do this? So I opened up my terminal, and I did this. J equals object, j.high equals there. And I get an attribute error. And this seems a little counterintuitive, right? Of course, J doesn't have the attribute high. We're trying to set it, right? It's not there, so we're trying to set it. Why are we getting an attribute error? Why doesn't this work? So keep that in your mind, and we'll talk about type for a second. And first, let's have like a little quick quiz. So does anyone know what the type of this list is? Shout out if you know it. List. List, right. Type of list is type list. That was an easy one. All right, what's the type of list? I heard object, I heard sequence. Type of list is a type. Okay, interesting. What's the type of a type?
Type. Object.
Yes, excellent answer. Type of type is type. It's like turtles all the way down, right? Type of type is type. This is a fun slide too, right? Type. All right, so here's some more. What's the type of none? I'm sure everyone has seen this one before. None type, right? And if I define this function, func, what is the type of the function? Does anybody know? Any guesses? It's function. So wait, this is a little weird because before we had list is a reserved word we use a lot in Python. But now we get function, and it's not a reserved word. We don't define a function by saying function something something. So where do these come from? There's a module called types, and when you look inside them, you get all the types.
Can you get the other screen to work?
To duplicate this? Yeah, sure.
Thanks. Sure. Let's make sure.
Great, we're in stereo now. All right, so there's a module called types. If you import it, all the types are in there. So you can do types, none type, they're all there. So while we have this imported, what's the type of types? What is it?
Module.
Right, module type. So we can do like this, types.module type is the same thing as the type of types. And one last one. All right, what if I define a class called PUG, what is the type of that class? All right, it's a trick question. This depends on what version of Python you're using. So in 2.7, this is a class obj, which is a mouthful. And in Python 3, or as I like to call it, Python, this is a little more confusing. It's a class type. And then if we want to kind of be like Python 3 but still work in Python 2.7, we do what we call new style classes. The class inherits from the object, and we get a type of type. So it's all different everywhere. But this in Python 2 is basically the same thing as in Python 3. And also from here on out in the talk, I'm just going to talk about Python 3. You can assume, when I instantiate a class, I'm not inheriting from object. It's just a regular Python 3 class. Okay, so if a class is just a type, right? When we say type of a class, we get type back. And calling a type with an argument such as 42 gives us the class. So the class of 42, or the type of 42 is int. That's a class. So we can instantiate it. We can put 2 parens after that, and we get 0 because when we say int with 2 open close paren, that's 0. We just instantiated an int class and we got 0 back. So if we can do this, can we just like instantiate a type? Just say type open close parens and do what Jeff originally wanted to do when he was irked? The answer is no, we can't do this, but we're close. So we get type error here, and it says type takes 1 or 3 arguments. 1 was originally what we were doing, and we gave 42 to type, and it told us what the class was. 3 arguments, you might ask, what are they? And the answer is, this is basically how we can dynamically instantiate a class. So the first argument is the class name, so it's a foo class. The second argument is the base classes, and the third is any attributes on that class. So now we've kind of come full circle, right? This is what Jeff wanted to do. He wanted to just have a string, like type something out, and then be able to say j.high and get the attribute there. So we really wanted to get fancy. We actually don't need to give it a class name, believe it or not. It can be an empty string. We don't need to inherit from anything, and we don't need to have any attributes. You can set it after the fact, and that's it. That's what he wanted right there. So we just instantiated a new class. It doesn't have a name in this example, but we were able to set the attribute on it and get it back. That's no problem.
It says it took 1 or 3 arguments. Could you just do j equals type tick tick, right, parent?
Determining the str.
So that would, the empty string is a string, and it would tell you that it's a str. Yeah, gotcha.
Okay.
So I wouldn't recommend doing this. It's a little cryptic, right, to have these like 3 empty arguments, but you could. So let's go back to this again. This is what he was originally trying to do. He's trying to instantiate an object, which you can do, but he couldn't set an attribute on it. Does anyone know why Python actually doesn't let us do this? Okay, good. So the main reason that this is failing is because set attribute is failing. So objects have no dunder dict. Does everyone know what the dunder dict is? Dunder dict is how instantiated objects hold attributes on them. So when we say j.high equals there, that's actually a class attribute, but on a normal object, that would be put into a magical dictionary, _dictionary, dict under _, and that's where it would be stored. And when you went to access it, it would look it up. So when I instantiate a class, it has this dict attribute, but when I instantiate an object, it doesn't. And the reason that it doesn't have it is because of size. If you look online, people will say a lot of weird things about why that's not there. The real reason is size, okay? So the size of an object, which is the top level of everything that exists in Python, is 16 bytes. The unit of this is bytes. The size of an integer, such as 0, is 24 bytes. They're still pretty small. It's an object. It's got a little bit of extra stuff to it. It gets bigger as the integer gets bigger, but it's still pretty small. The size of a dictionary, just an empty dictionary with nothing in it whatsoever, is an order of magnitude bigger. It's 280 bytes. So that's pretty big. So if we instantiate a class that is guaranteed to have this dictionary inside of it, it gets really large, 344 bytes. And so the reason that objects like integers don't have dict in Python, or just a regular object doesn't have a dict, is because everything would get huge in Python if they all did. So Python's doing us a favor, saying your integer doesn't need to have attributes. Doesn't really make any sense, so why even bother having it? As a quick side note, it's kind of it's non-trivial to figure out the size of an object in Python. There's a function in sys.getSizeOf, which will tell you the size of just the object, not recursively. It won't tell you the size of the dict or anything inside of it. So there's like I found a Stack Overflow function that I'm magically importing here to get the size of these things. But it's nice. If you ever try to, if you want to figure out the size of objects in memory, I'd recommend it. All right, any questions about type? All right, cool. So keep type in the back of your mind, and we'll sort of deviate for a second, and we'll talk about collections. I really want, it doesn't quite flow super well, but I want to talk about collections because I think it's a part of Python. It's built in the standard library that people don't use quite as often or as well as they can. So I want to introduce you guys to it a little bit, and then we'll move on to metaclasses. So let's imagine that I want to define a function called group. Group takes a list of names. So at the top, I'm defining my function. At the bottom here, I'm calling group with a list of names, Tom, Dick, Harry, and Guido. And what group does is it creates a dictionary where the key is an integer based on the length of the name, and the value is a list of the names that are that length, right? So Tom is 3 characters, Dick is 4, Harry and Guido is 5 characters. Does everyone get what the function is doing here? Cool. All right, so let's implement this in like a naive way, just throw it together. So we'll start with an empty dictionary because that's what we need to return. We'll iterate through each of the names. We'll make the key for the dictionary the length of the name, so that'll be 3, 4, 5. If the key is not in the dictionary, we need to set it. So we can't just set the key in the dictionary if it's not there. So we need to say d of key equals empty list if it's not there. And then if it is there, or after we just set it, we can say d.key append name. We're adding name to the empty list that's there, or the list that's already there. And then we're returning the dictionary, and this works. Great. So how many times when we run this function do we have to check and see if each key is in the dictionary? We have to check 3 times. We're checking once when we're saying if key not in D. We're potentially checking again when we're setting it D of key equals empty list. And then we're checking it a 3rd time, D key dot append name. So 3 times. So not super efficient. We can make that a little bit better. So dictionaries have a nice function called set default. And what it does is for a given key, it sets a default value, and then it returns the value that was set. So if it's not there, it gives you an empty list. If it is there, it gives you what was already there, which might be a list of names. So this is better. How many times are we checking it now? Twice. I would argue we're actually checking it once. Set default only checks it once. It checks it once to see if it's in the list. Set default does some stuff on the side, but here we're only really looking at it once. So I don't know about you guys, but when I see the D equals open close parens, that's usually like a code smell to me. I think, man, this would serve really nicely as a list comprehension. I hope everyone's like familiar with list comprehensions because I'm going to talk about it for just 1 second. So let's make this a list comprehension. So we can do this, but then it quickly kind of gets out of control because this actually becomes a polynomial time algorithm. For every name, we're actually iterating over the list of names each time, twice. So that's not good. So it's not always best to optimize by adding list comprehensions. But there is a better way. And that better way is default dict. So in Python, you have a collections module, and in the collections module, we have default dict. And what you can do is you can initialize default dict just like a dictionary. And what you do when you initialize a default dict, you give it a callable. A callable can be anything, but here we give it a callable list. When we call list, we say list open close paren, we get an empty list. So what default dict does is when something is missing from the dictionary and you're trying to set it or access it or whatever, if it's not there, it gives you the result of that callable. It calls that callable and then it gives it back to you. So what this lets us do is we create a default dict, we iterate through the names, the key is the length of the name, and we just blindly set D of key to append the name. Whether it's there or not, we don't care because default dict's taking care of it for us. It's going to say, all right, here's an empty list, or here's what's already there. And so this is great. And just one quick thing, I'm casting it to a dict at the return statement at the very end there, just because default dict, when I print it out in the terminal, it's like huge, it's lots of garbage, but it's basically exactly like a dict. You can access it, do everything exactly the same way. Yes?
So can you just run through one more time what the default dict does?
The default dict is exactly like a dictionary, except when you try to access a key, so when I'm saying D key.append name, if the key is not in the dictionary, it just gives you back an empty list instead, or gives you back whatever you set. So here I'm initializing a default dict. I'm giving it list, so it's going to call list every time something's missing and give me that back instead. Is that clear?
So this could be any callable.
Yeah, it could be anything. It could be an integer.
Returns, whatever you want the default to be,
Yeah,
whatever you want.
exactly. So we'll talk about that right now. So this is sort of a toy example, but I really like it. So one of the data structures that's not super widely used, but it's pretty neat, is called a tree, T-R-I-E, but it's pronounced the same way as a tree, T-R-E-E. And it's an ordered data structure that's used to store like usually it's used to store a dictionary. So if you have like a spell checker and you want to store all the words that are possibly able to be spelled, you might use a tree because it's a really efficient way to store these words. So like if I have the phrase Peter Pepper picked a peck of pickled peppers, I can store it in the tree and only store like the first character P once, right? And I can follow the path through this tree to figure out if the word exists or if it doesn't, right? If I try to move from P to a letter other than E or I, it fails. I say, oh, that's not in my dictionary of words. Trees are super useful for, they're used on phones, I think, mostly. So let's pretend that we're going to implement a tree. And what I'm going to do is I'm going to implement the tree kind of as a dictionary, right? I'm going to say tree, when I access it at B of A of R, and then set that equal to true. And this is, we're just going to imagine that this works. And then I check to see if it's equal to true, and that means the word is in the dictionary. When I try to see if tree of F of O is equal to true, it's false. That means that foo is not a word, but bar is a word. And if I printed out the tree, it would look something like this, right? It'd be a dictionary within a dictionary within a dictionary where the keys are individual characters, and the value is either another dictionary or it's true. So we can't just use like a regular dictionary because this would happen. It's a key error at B. We can't set something inside of B because it's just a dictionary that's one level deep, right? So how can we do this with a default dict that we just learned about? Import default dict. We set the tree to be a default dict of a lambda. That's cool. Lambda is just a callable, right? It's like an anonymous function. So every time the default dict is missing something, it calls this lambda. And so I have the lambda calling the default dict, and the default dict contains that callable as a dict. So I get a default dict of a default dict of a dict. So that works. I can set tree BAR equals true, and it works. Tree is in my dictionary. But then it fails again because in the last level, when I check to see if O is there, I get a key error because O is not in that last dictionary. So to make this work, I could make it a little bit longer. Make it, wait, sorry. We can't add words. What I'm trying to say here is we can't add words more than 3 letters for the same reason, because it's just a regular tree or a regular dictionary at the very bottom. We can do something like this. This would quickly get out of control, though, right, for long words. And it still limits the length of the tree that we support. Doesn't really make any sense. Kind of looks like Lisp with all those parens at the end. So let's not do that. So the really cool way that you can implement this is with something I would call an infinite dictionary. So again, we're just using a default dict, but our callable for initializing default dict is a lambda, the default dict of an infinite dict. So it's recursive. So every time you try to get an infinite dict, one level deep, it gives you back another infinite dict and just keeps calling that lambda over and over again and doing the same thing. So then this works. I can set tree of BAR equal to true, and that's there. Tree of foo, I can check it and it's false. And it works for longer words and everything. You might be like, wait, why does this work? It's not any different, like a lambda is not any different than any other recursive function. I could do this also, define a function called infinite dict, which just returns a default dict. It's recursive, returns itself. Still works, same thing. Any questions about my crazy infinite dict? Might be really useful if you ever work with JSON. That's where I've used it before.
So infinite dict is just, in the previous thing, infinite dict is just a variable that you define.
Yeah, I just defined it. It can be called anything at all. But I like infinite dict, it sounds cool. All right, another example of what we can use collections for. So let's say I want to define a function called count. Count also takes a list of names, just like group. But instead of ordering them by the length of names, it counts the occurrences of them in the list. So when I say count with a list of Beetlejuice, Guido, I get a dictionary. Key is the name, and the value is the number of occurrences in the list. Does that make sense? Beetlejuice has occurred twice, Guido has occurred once. So let's use default dict to implement that function. So we import a default dict. Count takes a list of names. D is the default dict, and here, like you said earlier, it could be any callable, so it's an integer here. Because we want that default value to be 0. That's what we get from when you call in, you get 0. For each name in the list of names, we'll add 1 to the value at D of the name, so get the dictionary by the key, which is the name. And again, we'll return the default dict as a dictionary. This works, but you might say, oh, it seems like I would actually probably want to do that really often and not want to write this function every time. And so the creators of this library, they were looking out for you. And so they created collections.counter. Don't ask me why it's a capital letter. I don't know. It's not a typo. So you can import counter, and you can just basically give counter a list, and it will return exactly what we want our function to do. It'll return a dictionary where the key is the items in the list, and the value is the number of times it's been in the list. So we really don't even need to make this a function. We can just call counter on it. All right, any questions about collections? Collections, there's a couple other things in collections too. There's a deck, which is a double-ended queue. They're pretty interesting, but not a lot of use cases for that, but it's really fast. Yeah?
What type does counter return by default?
What type does counter return?
Yeah, because cast as a dict there.
Yeah, cast as a dict. It would probably be like it'd probably be a counter. I'm not sure actually. Yeah, it'd probably be a counter. All right, now we'll talk about metaclasses in Python. But first, let's just talk about regular classes. You know it says metaclasses. Let's just think about a regular class. So if I define a foo class, does nothing. If I instantiate it twice, so A and B are both instantiated foo classes, and I say A is B, I get false. That's because these are two different instances. Their identifier in Python is different. They're different objects in memory. They're just totally different. So not the same thing. If I set some attribute on A, it's not going to get set on B, etc. A singleton, some people might have heard of this design pattern before. A singleton is a design pattern which allows a class to be instantiated only once. So this is useful in a couple different cases, but basically any subsequent time you try to instantiate a particular class that is a singleton, you only get back the first time you instantiated it, the very first instance. You only get one every time. So let's just implement a singleton class in Python. Our foo class is going to inherit from a singleton. And what we want the result to be is to instantiate two foo classes. And when we say A is B, we get true because they end up being the same instance. So first in the class, I'm going to create a class variable called underscore instance. I'm going to set it to none. And that's going to hold the instance for the class. And then we'll override the under new method. This is not the double underscore init method, which you might be familiar with. Init method is responsible for initialization. The new method is responsible for actually returning the instance. So when you instantiate a class, new gets called first, it returns the instance, then that instance gets initialized with double underscore init. So we're override new because we want to return a different instance. And what we'll do is we'll check and see if the class variable underscore instance is set or not. If it's none, we know that this is the first time we're initializing the class. And we'll initialize a new class. So this sets the instance to be a new object, which is just the parent of this singleton class here, with the same arguments and keyword arguments that we initialized the instance with. And regardless, we return instance variable, and then this works. Cool. So every time we initialize the foo class, we're always going to get the same thing back. Any questions about this? Yeah.
So then it only has the keyword arguments from the first time, as I recall.
Right, that's true. Yeah, that's definitely true. So the biggest potential problem with this approach is multiple inheritance. So if we inherit from another class in addition to singleton, and that class potentially overrides the underscore new method also, we might lose our singletonness, right? It might not work. We might actually end up getting another class back. So if we were to do this, we'd have to be kind of careful with it. We'd have to think like way harder than is really necessary, or harder than I want to think. So what we really want to do is we find a way to control the creation of each foo class. So we can do that with metaclasses. Metaclasses, this is the simile for understanding what a metaclass is. Classes are to instances as metaclasses are to classes. Classes create instances. So when you instantiate a class, you get an instance. Metaclasses create classes. When you instantiate a metaclass, we don't quite call it instantiation, but when you instantiate a metaclass, you get a class back. It creates a class. And metaclasses are nice because they also automatically handle the tricky inheritance, everything like that. So Metaclasses create classes. Can anyone name a metaclass in Python? Yeah. Who said it? Awesome. Type. Type is a metaclass. It creates classes. That's what we did here earlier. We said type of foo class, blah, blah, blah. And we created a foo class type. So how do we create a metaclass that's like type, that also creates classes? Oh, so also, you instantiate J. It's a class. We can instantiate, right? It gives us a class. So how do we create a metaclass just like type? The same way we create any other class. We inherit from type, and we've created our first metaclass. That's it right there. It's pretty simple. Since type is class, we can just extend from it just like this. And so how do we attach this to a class? In Python 3, there's a special keyword argument called metaclass, and you set your potential metaclass equal to it. In Python 2.7, it's a little different. There's like a magical class variable that you set equal to, but let's just think about Python 3 for now. To make metaclasses really useful, we have to override the new function, just like we did for the singleton class. But this time, new isn't going to return an instance. It's going to return a class, because that's what metaclasses do. They make classes. So in the same way of calling type with a name, we're calling the super of metaclass, which is type. We're calling new, and we're giving it the name, the bases, and the attributes of the class we're trying to instantiate. And by the way, there are like so many names for these 4 arguments that we can pass to new for metaclasses. There's not really any consistency. This is kind of just what I like the best. But the arguments are meta, which is the parent class, the name of the class, the bases, and the attributes, just like when we were doing it with type before. So just to be clear, when new gets called for a metaclass, this is when it gets called. I haven't actually done anything. I just created a foo class, said the metaclass was my meta, and created it, and then new gets called. It's been created. That's when this print function that I stuck in here gets printed out at the bottom. On the other hand, the underscore call method gets called when we actually call a class, when we instantiate a class and expect to get an instance back. So we can override this function. I stuck a print statement in here, and you can see nothing happens when I create the class, but when I say f equals foo class, open close paren, that's when call gets executed. Any questions? All right, so let's make the same singleton, but this time we'll use the metaclass. So my foo class is going to have metaclass of singleton. I'm sorry if you guys can't see this very well. There's a lot on this slide. But in the end, we want to say A is a foo class instance, B is a foo class instance, and A is B. So we'll create a class singleton. It will extend from a type. We'll override new. In the same way that we did before, we're going to have a variable which holds the instance, but this time we need to set it on the adders dict for our new class. And we'll return the instantiation of that class. So you see how I sort of stuck that metaclass variable in there. And then we'll override call as well, because that's what we want to actually return the instance when we call the class. It'll check that class, the underscore instance variable that I created. And if it's not there, it'll return the new instance. If it is there, regardless, in the end, it returns the instance. And this works. And it's metaclass. We don't worry about inheritance. We don't do anything. It's really nice. To be explicit, because someone pointed this out when I gave this talk once before, this is not thread safe. If you have multiple threads running for whatever reason, and you want to do a singleton, you're crazy. It doesn't make a lot of sense. But you could have like multiple singletons in different threads, and they don't communicate with each other, so it won't necessarily work. All right. Any questions about metaclasses? Okay, cool. So in case you somehow didn't learn anything in the beginning of this talk, I'm going to make sure everyone has something to take home with them. I want to learn something new about Python. So we're going to talk about some watts in Python. If you've never heard the term watt before, a watt is like an edge case in a language. And when you look at it, you're like, what? Like, it doesn't make any sense. Why does it do that? But it's something that's built into the language that happens. So this is going to be interactive. So I'm glad that people have some laptops. But here's a quick example to get started. number 0. So what we want to do here, the goal is to determine first if this is actually possible or not. So can we create a variable x so that when we compare x with itself, it says false, x is not equal to x. So if it is possible, what we want to do is we want to replace the ellipsis, the 3 dots, with anything to give us the desired results. So the missing values in these watts, there's going to be 10 of them, are only going to be the built-in types. So they're going to be like bools, ints, lists, tuples, dicts, sets, strings, and none. That's it. So no lambdas, partials, any of that tricky stuff. All right, so I'll give you like 10 seconds to think about this. And then I'll ask for a show of hands. Who thinks that this is definitely not possible at all in Python ever? Raise your hand. Okay, cool. So you guys all know the answer, right? So what's the answer to this? It is possible. How can you do it? Does anyone know? Yeah.
Is it none?
It's not none. None is equal to itself.
Is it a dictionary? Is it an empty dictionary?
Empty dictionary is also equal to itself. So the answer is float of the string NaN, which is how Python represents not a number. When you compare not a number with itself, not a number is not equal to not itself. You can't compare things that aren't numbers. I would also have accepted 0 times 1 times 10 to the 400th power. This is also how Python can represent not a number. It's weird, right? X is not equal to itself. That's crazy. Okay. So I have a little quiz online. It's 10 questions. I want to see if you guys can roll through it. If you're interested in playing along. And at the end, we'll go over all the answers and see if we've been able to figure any of them out. Honestly, they're all pretty hard. I didn't create these. I found these online. I think they're super cool. But as a quick disclaimer, I don't think you should like ever use these questions in interviews. They're like they're insane edge cases, and they're like cool riddles, right? It's like, oh, how could you possibly do this? And just don't ever ask these in an interview. All right, so this is the site, python-watts.herokuapp.com. There's 10 questions. They're not trick questions. Some of them are impossible though, so you'll have a little button. It'll say not possible, or you will be able to fill in the inputs to make it possible, and then you can click possible, and you go on to the next question. You get an exception. I'm using this weird in-browser Python library. You get an exception, it just means you're doing something wrong. You should be able to put the right answers in. And so I'll give you guys like, I don't know, 15 minutes or so. Feel free to talk amongst yourselves and cheat and do whatever. Yeah, good luck. I should play some music right now. Oh no, I'm not online. This doesn't work.
I was trying to be this busy. So I want to solve stuff like a list. Or just there's a list from 0 to 1. So the first round. If I take 0 to -1, first last one, 0 minus 2, plus 1 further back.
I apologize, everyone's doing it on their phones. I know it's not super responsive. Didn't really think about it.
Works all right.
I hope it works though. Your faces are great too. As always. That's not possible.
You're a sadist.
All right, I think I'll give it about 5 more minutes. Most people are still on question 1. All right, one more minute. All right, if you haven't finished quiz, you can probably just click next possible or not possible until you get to the end, get your score, and we'll go over the answers now. So if you got 4 out of 10, don't feel bad because that's actually what I got when I first took it. That means that you marked not possible for all of them, and 4 of them were not possible. So you got 4 points just as a little bonus. Great job.
Is that
Yeah.
really how you answered the first time?
What's that?
Is that really how you?
Yeah, I couldn't get any of these guys, honestly, the first time. So I'd be really impressed if anyone got even one of them. They're pretty weird and hard. So let's talk about them. So number 1 was if we can create a list such that when sliced by A, B, and C, the maximum in the list is less than the maximum of that slice of X. Does anyone know if this is possible or not? With like stern assurance? No? Okay. Anyone want to stake their claim? No? All right. This one, not possible. No matter how you slice the list, it's always going to be a subset of that list. And so the maximum of the list is always going to be the biggest thing on the list. It's never going to be smaller than the max of some slice. So no matter how you slice it, it's always the same.
Made them all at least possible. That's way too much time.
Well, I mean, the idea is like you should recognize, no, like that'll never happen, right? You just kind of screw with you a little bit.
Question.
All right. The second one, can we make, yeah, seriously, no interviews. That's the disclaimer. So can we make number 2? We make x and y such that when we say min of x and y, it is not the same as the min of y and x.
Yes.
Yes. Okay, awesome, cool. We got this one. So it says you use sets, right? If you use what? Or nan, right? Okay, that's a little bit cheating.
That's the answer a lot of the time.
Oh, maybe I should have specified no nans. I didn't realize. Okay, so the answer I was looking for here was sets. So if you try to take the min of 2 sets, they're not the same. And but it's only if x and y are sets though. And so you might ask why. So when we say min of 0 and 1, we get set of 0 is the smallest. When we say min of 1 and 0, we get set of 1 as the smallest. You might be like, oh, okay, min is broken. It's just giving us the first element. If we do this, we say the min of the set of 0 and 1 and of 0, we get 0. We get the second argument. So real quick, let's just imagine what min is doing when we give it these arguments, right? So min takes any number of arguments, and it tries to find the smallest of all of them. And it also takes an iterable, but we're just going to pretend like that doesn't happen for now. So this is just a naive function. We want 2 variables, has item and the minimum item. Has item is false. That checks to see if we've found the minimum item yet. Min item is the minimum item that we're going to store it there. We'll go through all of the elements in args, and if has item has not been flipped to true yet, or if the element that we're looking at right now is less than the minimum item that we've seen so far, we set has item true, minimum item with x, and we return the minimum item. That's like not actually how min works at all, but that's just like a really boiled down version of it. So what's the key here? The key is this less than operator here when we're saying x less than min item. When we compare sets with the less than operator, it's overloaded. It's actually the inclusion operator. We're saying, is everything in set 1 in 0? Or sorry, is everything in the set of 0? Or everything in set of 1 in 0? So it's false when we do a set of 1 less than 0, but it's true if we say 1 is less than 0 to 1. Because we're saying the element 1, everything in 1 is in elements of 0 and 1.
So the argument changes the entire meaning, intuitive meaning of min.
Right, yeah, it depends on what you're giving it, right?
It takes the less than operator. So no,
yeah, it's because the lesson, so you just have to understand the lesson operator is overloaded. It doesn't always just compare these by.
So it occurs to me, so before you gave the punchline, I thought that I figured it out. I thought that min was actually comparing the cardinality of the set.
Oh,
Which
okay.
I think would give the same result.
Yeah, I think it might, yeah. But min doesn't use
now
it.
I feel like this is a less intuitive way to overload than the other way.
Perhaps.
Probably more useful, just less intuitive.
So, right, since it's the, anyway, since it's the inclusion operator, we get min of 0 and 1 instead of 0. All right, number 3. Can we create 2 lists, x and y, such that at least one element in x is true? So we pass a list to any, it checks to see if any of them are true, or truthy, and not any x plus y. So that means when we append y to x, none of them are true. Anybody know? Not possible. Definitely not possible. No matter what you put in y, it will not have any effect on what is in x. So if something in x is true, any is always going to return true, no matter what you append to x. Okay, cool, good job. Number 4, can I create 2 variables, x and y? So when I count the occurrences of y in x, it occurs more times than the actual length of x. Anyone know if this is possible? This is a fun one. It's possible. If we make x a string, a single character string like a, and y an empty string, when we count the occurrences of the empty string in a, we actually get a value larger than the length of a. We get 1 for the length of a, and we get 2 for the occurrences of empty strings in a. This is a little weird. Doesn't make a lot of sense, but it's only for the empty string, and the reason is the way count works. So let's also imagine the way Python's count function works on strings. So let's make a function that takes string and a substring, and we'll search for the substring in the string. And we'll have a variable result. That's the number of times the substrings occurred. We'll iterate through all the indexes in which the sub could start next. So it'll be could start first, second, the third, but it needs to end the length of the substring from the end of the string, right? We don't want to like overflow the length of the string when we're searching. So if the substring is the same size as the string, we get one index, 0. So basically just comparing two strings. If the substring is smaller than the string, we get all possible start indices. So it could be less than the length of the string. But if the substring is an empty string, an interesting thing happens here. Len of sub is 0, but we're still adding 1 to the length of s. So we get a range of 2, which is indices of 0 and 1. So it's one more than the length of the string that we're searching. And then when we compare the possible matches, we have the possible match is this slice of the original string of I plus the length of the substring. So the length of the substring again is 0, so this is a slice of nothing. And we get an empty string. Slice of anything, any list is just going to be an empty string when these values are the same. And it won't raise an index error because when the index is longer string, because that's how slice works. So count will return the result and increment the result if possible, return it. And this is what the function does. When we give it a string and an empty string, we get 2. And that's why. That's why the count of an empty string is more than the length.
Why doesn't it check the length of s in the sub?
I don't know. it just doesn't. You can kind of think of it like that there is that many empty string, like there's an empty string before and after the character A. If it was 2 characters long, you'd get 3. It'd always be 1 more, but
Probably that's not probably on Reddit so much, right?
Yeah, if you come from
Yeah.
Reddit.
Yeah.
That's a good point. Yeah. So I'm sure there's a good reason for all this stuff, right? You should also know that this is not actually exactly how count works. So count counts the non-overlapping substrings. So my function would do this if I had a string like FO, FO, F, but the actual count function would just return 1 because it would be overlapping. So just want to point that out. It's just a toy function. You shouldn't try to implement standard library functions by yourself. All right, so number 5. Can we create 3 variables x, y, and z such that when we multiply x by the result of y times z, it's not the same thing as multiplying x and y by the value of z. So yeah, I guess if you use nan here, it would work. I should have just like, and I didn't even think of it. Even after talking about nan, it didn't occur to me. But yeah, nan would work here too. The actual answer that I was looking for though was this. It's possible. If we make x a list and y and z -1, an interesting thing happens. On the left-hand side, x times the value of y and z is the same thing as 0 times -1 times -1. -1 times -1 is, of course, 1, and anything times 1 is itself. So we get 0 times 1, and that's the same thing as 0. These are all the same, right? On the other side of the double equal sign, we have x times y, the product of x and y times z. So when we multiply any list by -1, does anyone know what happens when you multiply? Does anyone know what happens when you multiply a list by any integer? It repeats, right? You get the same thing n times. You multiply by a negative integer, does anyone know what happens? So if you multiply by a negative integer, Python assumes that you actually meant 0. And it's the same thing as multiplying the list by 0. Values of n less than 0 are just treated like 0. You can't really like multiply a sequence by a negative number. So it gives us an empty sequence of the same type as the original sequence. So in this case, it would give us an empty list. So it's a string, it gives us an empty string. And so that means that when we multiply this array by -1, we get an empty list. Again, multiply by -1, again, empty list. These things are not the same. So order of operations kind of is important here. And you assume that for integers, it wouldn't run.
I thought you just spelled code review when you multiply a list like that by -1.
What's that? Say again?
At most places, you would fail the code review if you did that.
Yeah, that's true. Yeah, you don't want to use this in production, probably. Okay. Number 6. Can we make 2 lists, x and y, such that x is less than y? So when we compare 2 lists, it's lexicographical ordering. It's like alphabetization. So 2 lists, x and y, x comes before y, or is less than y, and However, every element in X, I'm going to say this right. I want to make sure I say this right. Every element in X is greater than or equal to every element in B.
So it's not cross product, it's just parallel.
It's pairwise, right? Yeah, it's pairwise. You're comparing each element in each list together. One list comes before the other, but the other one, when you compare the individual elements, they're all greater or equal to.
But if the length is different, because zip makes it not. No, it doesn't.
Yes, that's exactly though. That's exactly what it is. So this depends on a couple things. So if X is an empty list and Y is a single element list, this is possible. What happens is when we compare these lists like this, the empty list always comes before a list of any length. So when we use the less than operator here, it says true, empty list is less than a list with any number of elements in it. When we zip two lists of uneven length, what it does is it gives us a list that is the shorter length of the two lists. So everyone knows what zip does. Zip takes two lists and it just pairs everything up in them until you get to the end. And when you get to the end, if you have excess in one list, it just throws it away. So here, when I zip an empty list with a list with anything in it, it just gives me another empty list. And so then the third key to this what is that all of an empty list is always true, because it all is like short-circuited. It goes through everything in the list, and it says, until I find something that's false, return false, otherwise I'll just return true. Since there's nothing for it to iterate over, it just returns true. And so then this is possible. Number 7, can I create a sequence X such that when I cast it to a list, then to a set, and get the length of it, it's not the same as first casting it to a set, then casting it to a list, and getting the length of it. Does anyone know this one? This one is definitely not possible. So converting a list to a set, it might reduce the length of the number of elements, right? If you have duplicates in your list, your set might get smaller. It might be a smaller length because they're all unique. But converting a set to a list will never add elements. So no matter what order we do this in, the cast to a list to a set, or the cast from a set to a list, is always going to be the same length, guaranteed. Also, I don't know if you guys, anyone did this particular question in Google Chrome, but when you load in Google Chrome, it thinks that the page is in Slovak for some reason and tries to translate it for you. So if anyone can tell me why, it's like a huge mystery to me. I don't know. It does it every time. All right, number 8. Can we make an X such that the minimum of X is not the same thing as the minimum of X unpacked? So unpacking takes the iterator and expands it into arguments, right? Does anyone know if this one's possible or not?
Got it by accident.
By accident. And what's the answer?
It was a list containing a single list.
Yeah, exactly. That's totally right. So nice job. So remember earlier I said min could take either a series of arguments or it could take an iterable. This y exists because of the way min treats its arguments. So when I do this, when I say min of a list, it's the same thing as saying min of the list unpacked, which is the same thing as saying min of the arguments 1, 2, and 3. It's all the same. It's always going to return 1. But if the min of x, so the min of this of x, when it's just a list of a single element list, it's going to think of it as an iterator with only one element, and then it's the minimum of a single element sequence is just going to be that element. So it returns the list of 0. But when I unpack the list, the min of x unpacked is the min of the list containing 0, and that's 0. It thinks that it's now, all right, this is an iterator I got to use, and it goes through it and it says, okay, the smallest thing I found is 0. So this is totally possible. All right, number 9. Can I create two values x and y such that when I multiply x by 0 and sum it, so x is going to be a sequence here. When I multiply x by 0 and sum it, starting at the value y, I don't get y. I get something other than y. So in case you don't know how sum works, sum takes a sequence, and it can optionally take a second argument, which is the starting value of the sum. So if that, this is the y is the starting value. So anyone know if this is possible?
I think so.
You think it's possible?
I think it's possible if x is a list.
X is a list. Okay. So if X is a list and we multiply it by 0, what happens? What do we get?
We get the empty list.
So the sum of an empty list, what happens if we try to sum an empty list?
We get the empty list. But if y is another list, we get the concatenation of lists. And if we concatenate a list, empty list, we get that list back, right?
Interesting. I hadn't actually, that's possible, yeah? No, it doesn't work.
Sum of an empty list and an integer is the integer itself.
It raises an exception, right? Yeah? No, empty list?
So y has to be an integer in this case.
Okay, yeah, y definitely.
Okay.
I wasn't sure actually if you could give it but y needs to be an integer. All right, so this is impossible, I think. You're making me second guess myself.
Well, the thing is, I don't think the multiplication operator is commutative though. So I don't know if can you do 0 times a list and a list times 0 and get the same thing?
Yeah, it'll be the
Okay,
same
it's
thing.
commutative.
Yep.
I think X is a list with 0 as an item and Y is float man.
More than hands. Oh man, you're killing me. Pretend like that doesn't work. So this is what happens when we sum a list of ones like this. Starting value of 7, we get 10. If it's an empty list and that's an integer, we get 7. So this will always fail. You're always going to get, unless you use a nan, I guess. You always get this. I'm going to talk about nan for like a quick second at the end of this, just because I want to address why this is occurring. All right, the last one, 10, is my favorite one. I don't think, well, maybe nan might work for this one. I don't know. Oh, no, nan won't work for this one. So, oh well. For number 10, is this possible? Can we create two values, x and y, such that y is greater than the maximum of the sequence x, but y is also in x? Does that make sense? Does anyone know if this is possible? Did anyone get this one? Cool. So it's possible if x and y are both the string, both the two sequence string like this, AA, this works. So the max of the string AA is the character AA. That's the biggest character in the sequence of that string. But when we check to see if AA is greater than A, it is. This is like comparing the words dog and dogfish. Dog comes before dogfish, even though dog is a substring of dogfish, right? So AA is greater than A. And last, you need to understand how Python treats the in keyword with strings. So when I say like a value is in a list, something in list, it checks to see if it is an element in that list. But for strings, when you say AA is in AA, it's checking to see if the substring AA is in A. It's a little bit different than what you do with regular sequences. So this is true. So this ends up working. This is totally valid Python. Okay. Any questions? Yeah.
So I'm guessing most of these haven't been fixed because it would slow down the built-ins too much.
They haven't been fixed because they're not bugs. They're edge cases. They're not necessarily bugs. This is the way you basically expect everything to behave. You'd have to add some just like special checks to see, if you wanted to make this seem reasonable. But like, this makes sense. Those three things at the bottom there, the max of a string, you want to get the biggest character in the string. You want to compare strings like that. You want to check if the string is in another string. Those all work. So when we combine them, that's when you get the weirdness happening. But it's not really like a good way to fix this. And it's not really a problem necessarily because I guarantee it, you'll never encounter these. So don't ask your interviewees any of these questions. Yeah.
I just wanted to make a follow-up comment about that. I think, with a lot of these, when I first saw the problem statement, I had this perception of like seeing it as math on numbers. And I had to think of it as, okay, what else could it be besides just numbers?
Yeah.
If you think of it as numbers, they're all impossible.
Yeah.
But because they can be things besides numbers, because they're sequences and strings and so forth, you have to kind of like override our intuition about it, and then it makes sense.
Right. Exactly. Yeah. Yeah. It's more about understanding, how Python can use the same operators for combining numbers and sequences. I tried to hint at that a little bit in the quiz. Some things are defaulting to a list, but yeah. Was there another question over here? Yeah.
Can we go back to number 3?
Sure. You're gonna tell me that not a number works for it?
No. I'm sure I'm wrong, but okay, suppose X is an empty list, so any of X would be true. and suppose Y was a list with a 0. Then wouldn't the empty
So-
list plus Y be 0 give you a list 0, and that would be false?
Does anyone know what any of an empty list is? It's actually not true, I believe. All of an empty list would be true, but any of an empty list short circuits an observation
false.
and returns false.
Okay.
So this wouldn't work. It's good to understand how those work with empty sequences, though. They might produce results that you don't expect. Any other questions? Okay, since I had talked about not number earlier, and it turned out to be an answer for a lot of these questions, I just want to sort of digress for a second and see if anyone understands why not a number was actually making most of these things work. You guys know why you can't compare not a number with a non-number and get true, why it's basically incomparable to anything else, and why it was sort of making these things work. Do you guys know? You kind of probably encounter this a lot if you work with like NumPy or SciPy or something like that, because there's a lot of non-numbers occurring in there. Basically, if a non-number occurs anywhere in a calculation or anything that you're doing, you don't want it to just like silently disappear, right? If I'm comparing two things and they're both not a number, I don't want that to just go away. I want that to be false. If a non-number is in a sequence or something, I want that to sort of like bubble up through and end up in my final result, because I know something's wrong. You don't want it to just silently go away. So that's the reason why non-number was working for a lot of these things. In the future, I probably won't introduce that in the talk, so the quiz will go a little more smooth. But kudos to you guys for realizing that that could potentially work. All right, thanks, guys. If you have any questions, feel free to talk to me afterwards. I'm also pretty active in the Philly Dev Slack. There's a Python channel. I invite you all to join it and chat. And yeah, thanks for coming out.
Thank you.